Hello everyone, myself Vinay Kumaram. I am actually pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my YouTube channel. I was actually teaching the fifth chapter of 8th standard mathematics, which is squares and square roots. So I have already uploaded part 1 video and part 2 video of the squares and square roots, and this is actually part 3 video. So if you want to understand squares and square roots properly, then please watch part 1 and part 2 video and then watch this part 3 video. So in part 1 video I have explained about squares, and in part 2 video I have explained exercise 5.2 and exercise 5.1. So in this part 3 video I will be discussing about square roots. Along with that I will be discussing about the remaining exercise questions. So what do you mean by square roots? So we all know that the word root means the origin. Like if you consider a plant, if you consider a tree, then that particular tree will be visible on the ground, but the roots which are attached to this particular tree will be invisible. Means it is not actually invisible, it is actually below the ground on which this tree is actually standing. That means for this particular tree to nourish, these particular roots are actually helping. So similarly, if you have a square number, let's say you have 4 as a perfect square number, then this particular square is actually the multiplication of 2 with itself. That means 2 into 2, and then it has given the answer 4. So this will act as a square number, and the root which is actually responsible for this square is actually known as square root. So you should always remember the root means the origin from where that particular number has origined. So 4 is a perfect square because when 2 is multiplied with itself, you are getting the number 4. That means 2 will act as the root of that particular square number. So that's why 2 is known as square root of 4. So you should remember this particular term. So how will you find square roots? In my previous video, I was actually explaining how to find squares. So if you have a number 26, how will you find 26 square? So you will actually do it as 20 plus 6 whole square, and by using a plus b whole square formula, you will actually simplify this and you will actually add the terms which are there. So thereby you will get the answer for 26 square. So now if I give you a number, let's say 16, how will you find the square root of this particular 16? So first method, so I am actually teaching the first method here. So method 1 to find square root of a perfect square number. So if you refer my previous video, there I have actually told about the addition of consecutive odd natural numbers starting from 1. Like 1 plus 3 plus 5 plus 7 plus 9. So if you go on adding consecutive odd natural numbers starting from 1, then you will go on getting perfect square. Just like 1 is a perfect square, 1 plus 3 is 4, 4 is a perfect square. So 1 plus 3 plus 5 is 9, 9 is a perfect square. So 1 plus 3 plus 5 plus 7 will give you 16. That is also a perfect square. So 1 plus 3 plus 5 plus 7 plus 9 is 25. That is also a perfect square. So if you want to understand this, you can refer my previous video for this. So using this, we can apply this method in a reverse manner to find square root. So if you get a perfect square number like this, 16, so you can go on subtracting one odd number, like consecutive odd numbers you can take, and you can go on subtracting with this particular perfect square number. So I'll show you how to do that. So the first odd natural number is 1. So you just subtract 1 from this 16. So you'll get 15. So take this number 15 and subtract it with the second odd natural number, that is 3. So 15 minus 3 will be 12. So you got 12 as your answer. Now again subtract this 12 with the next consecutive odd natural number after 3, that is 5. So 5, 12 minus 5 will be 7. So take this 7 and subtract that with 7, because here the next consecutive odd natural number after 5 is 7. So 7 minus 7 is 0. So if this particular number which you have taken in the start, if you go on subtracting with odd numbers starting from 1, then if you are ending with 0, then that shows this particular 16 is a perfect square. So this is one particular method which you can use to find a particular number is actually perfect square or not. So if you take 17 in the place of 16, then if you go on performing this operation, so finally you will get 1. So if you subtract 1 with minus 9, you will get some negative numbers. That means it is not approaching to 0. So here 16 is approaching to 0, even 9 will be approaching to 0. So let me take 9, because 9 is also a perfect square. So 9 minus 1 is 8. So 8 minus 3 is equal to 5. So you are actually subtracting the odd natural number starting from 1. So take this 5 and subtract with next particular odd natural number that after 3, that is 5. So 5 minus 5 will be 0. So here also you can see this particular 9, after going on performing this operation, finally it is approaching to 0. Here also 16 is approaching to 0. So perfect squares, when you go on subtracting that particular perfect square with consecutive odd natural numbers starting from 1, then it will approach to 0. So that will actually give you an hint that that particular number which you have taken is actually a perfect square. So now how to find square root from this? So you should just count how many odd consecutive natural numbers you have subtracted to get this 0. So you just go on listing how many odd numbers you have actually used to make that 16 0. So how many odd numbers you have used? 1, 2, 3, 4. So you have started from 1 and you have used 4 odd numbers to make that 16 come to 0. That means here square root of 16 will be 4, because you have subtracted 4 consecutive odd natural numbers to get 0 of that particular perfect square. To make that perfect square 0, you have subtracted those many times. So that will be the square root. Here also you can see when you add 1 plus 3 plus 5 plus 7, you will actually get 16. That means when you add 4 consecutive odd natural numbers starting from 1, you are getting a perfect square 16. So similarly, when you go on subtracting this consecutive odd natural numbers with 16, finally you are getting 0. That means that many times you are actually subtracting. So how many times you are actually subtracting with odd numbers? So that you should actually count, and that will be the square root of that particular perfect square number. So here to make 16 equal to 0, so to make 16 0, you have actually 4 times subtracted this with odd numbers starting from 1. So here square root of 16 will be 4. So this is one particular method to find square root of a perfect square number. So here also you can see, to bring 9 to 0, you have used 3 odd numbers starting from 1. So that means here square root of 9 will be 3. So you should always remember, you should start subtracting this particular perfect square with 1, and you should go on doing that with consecutive odd natural numbers until you get 0. So if you are not getting 0, then the number is not perfect square. If you are getting 0, then count how many odd numbers you have subtracted to make it 0, and that many that number, like how many odd numbers will be there, so that will be the square root. So this is one method. So there is another method to find this particular square root. So if I give a number 6,400, then if I tell you to calculate the square root of 6,400, then if you try to use this method 1, it will be a very lengthy process, because here you should actually take each and every odd numbers and you should go on subtracting. So how many times you will do that subtraction? So it will actually consume your time. So for that we have second method. So how to find square root of a particular perfect square? By using method 2. Sorry, this is not 1, this is actually method 2. So here in method 2, you can actually find out whether a number is perfect square or not, and you can also find the square root of that particular number. So now let us go on taking prime factorization of this particular 6400. So whenever you take LCM of a particular number, whatever prime numbers you go on using to find LCM, you just go on doing that by using prime numbers. So you have 6400. So just go on doing prime factorization. So 6400, you can actually divide this by 2. So when you divide it by 2, what you will be getting? You will be getting 3200. Similarly, if you use 2, you will get 1600. So again, when you use 2, it will be 800. When you use 2, it will be 400. When you use 2, it will be 200. When you use 2 again, it will be 100. When you use 2, it will be 50. When you again use 2, it will be 25. So when you use 5, it will be 5. When you use 5, it will come to 1. So after doing prime factorization, you should only take prime numbers. Here 5 is prime number, 2 is prime number. So after doing this prime factorization, so this method 2 is actually known as prime factorization method. So after doing prime factorization of this particular 6400, you are getting so many numbers. So now you can actually write this 6400 as the multiplication of these many prime numbers. You can count how many numbers you have used. 1, 2, 3, 4, 5, 6, 7. So 7, 8. Here 1, 2 is there. So 8 times you are actually multiplying 2. 2 into 2, 2 into 2, 2 into 2, 2 into 2. So like 8 times you are multiplying it with 2, and then you should actually multiply 2 times with 5, 5 and 5. So into 5 into 5. So when you do multiplication of this, you are actually getting 6400. So now, if this particular 6400 is a perfect square number, then there will be a pair for every prime numbers which has got multiplied to get 6400. So this particular 2 will get paired with the next 2. Similarly, this particular 2 will get paired with next 2. So this particular 2 will get paired with 2. This particular 2 will get paired with this particular 2. And their 5 is actually getting paired with another 5. So let's say if you have one more 5 here, let's assume that. So at that particular time, this number will not become a perfect square because one single term will be left out which doesn't have any pair. That means it doesn't have any own number to get paired with. So now 5 is there means another 5 should be there to get pair up. But it doesn't contain another 5. That shows this particular 5 is left alone. Then that particular number will not be perfect square. But here this particular 5 is not there. So all the numbers are getting paired with each other. So in square, whenever you get square, you are actually multiplying a particular number with itself so that you will get a perfect square. So here also you are actually splitting that particular square into prime numbers, like the multiplication of prime numbers, and you are grouping those prime numbers. Take one number because here 2 times 2 is multiplied. So take one number because you are finding square root. So find square root of this. So 2 into 2. What is the square root? Will be 2. So what is the square root of this? It will be 2. What will be the square root of this? That will also be 2. What will be the square root of this? That will also be 2. What will be the square root of 5 into 5? That will be 5. These are all grouped prime numbers where you are taking one term from this particular paired group numbers. So now whatever numbers you have got here, you just take it and multiply. 2 into 2 into 2 into 2. So 4 times you have got 2 because here 8 times 2 is there. So the square root of 8 times 2 will be the 4 times 2. That means 2 should be multiplied 4 times with itself. So 1 5 is there. So you just multiply that 5 here. So 2 into 2 into 2 into 2 5. So now you just multiply. When you multiply that, you will get 2 into 2 4, 4 into 2 8, 8 into 2 is 16, 16 into 5 is 80. So 80 will be the number. When you reduce that to single quantities and when you multiply that, you will actually get 80. That means square root of 6400 is 80. So after learning these two methods, you have one exercise here, that is exercise 5.3. So let us go on solving exercise 5.3. Coming to the first question, they have given 5 different questions and they are asking what can be in the unit place of the square root of these particular perfect numbers, perfect square numbers. So the first question is 9801, the second question is 99856, and the third question is 998001, and fourth question is actually equal to 657, 3 times 6, 025. So by looking at these particular numbers, you should actually guess what might be the square root of this particular number, what will be there in the unit place of that particular square root number. So if you refer my previous video, I have mentioned two properties of square roots where I have explained whichever square root is ending with 1 or 9, then that particular square root, that particular number's square will be ending with 1. That means perfect square, if it has 1 in its units place, then its square root will be having 1 or 9 in its unit place. So here this 9801 will be having certain number as its square root. So this particular number will have either 1 or 9 in its units place. So this is only the answer you should actually find. So here this particular perfect square has 6 in its unit place. Similarly, like this property, there is another property which states if square root has 4 and 6, then its perfect square number will be ending with 6. That means if square root is ending with 4 or 6, then the square of this particular square root numbers will be ending with 6. That means square of this particular number will be ending with 6. So here also perfect square is ending with 6, then its square root will be having either 4 or 6 in its unit place. So this is the answer for this particular second question in this particular first question. Coming to the third question, here also it is ending with 1. So the unit place of square root must contain 1 or 9. Here also you can see 25 is actually getting ended, or 5 is actually getting ended. Then the square root of this particular perfect square will end with 5. So you should always remember, if a perfect square is ending with 5 means, then its square root will also be ending with 5 only. So the answer is 5. So coming to the second question, there again they have given 4 questions where first question is 153, second question is 257, third question is 408, and fourth question is actually 441. So this is the 4 numbers which they have given in this particular second question, and without doing any calculation you should find out whether these numbers are perfect squares or not. So here which numbers are not perfect squares, that you should actually identify. So if you refer my previous video, I have mentioned no perfect square will actually end with 2, 3, 7 or 8. So perfect square will be, most of the times it will be not ending with 2, 3, 7 and 8. So here you can easily see this particular number is ending with 3, this particular number is ending with 7, and this particular number is ending with 8. So here first one, second one and third one, that is 153, 257 and 408 are not perfect square. So these 3 numbers are not perfect square. So I'll just write not perfect squares. So this is the answer for second question. Coming to third question, using method 1, that is by repeated subtraction of odd numbers, you should actually find square root of 100 and 169. So if you want to find the square root of 100, you should go on doing repeated subtraction of odd numbers starting from 1. So 100 minus 1 will be 99, 99 minus 3 will be 96, 96 minus 5 will be 91, 91 minus 7 will be 84. So 84 minus 9 will be equal to 75. So 75 minus Next odd number is 11. So 75 minus 11 will be 64. So 64 minus 13 will be 51. So 51 minus 15 will be 36. So 36 minus 17 will be 36 minus 70. So it will be 20, 19. So 19. So 19 minus 19 will be equal to 0. So now you can see, after going on doing repeated subtraction starting from 1 using odd numbers, we are reaching to 0. That shows 100 is a perfect square. So how many odd numbers we have subtracted here? 1, 2, 3, 4, 5. This is 5. 6, 7, 8, 9, 10. That means 10 times we have actually subtracted with odd numbers starting from 1. So the square root of 100 will be 10. So 10 is the answer for this 100. You should all perform this particular activity, and then only you should actually conclude that square root of this particular 10. Because in this third question they have specifically mentioned using repeated subtraction. That means you should use this method only to find square root of 100. Similarly, you can find square root of 69, where you will get 13 as answer, but you should actually follow this particular method and only find out the square root of 169, because they have specifically mentioned by repeated subtraction. Coming to the fourth question, they have actually given so many questions, like they have given 10 questions in this particular fourth question. Using prime factorization, you should go on finding square root of that particular questions, whatever they have given in this fourth question. So I cannot solve all 10 questions here. So I'll be solving 3 questions. So remaining 7 questions you should actually solve using prime factorization method. So coming to the first question in this particular fourth question, it is 729. So let's go on doing prime factorization of 729. So 3, you can take 3. So if you divide 729 by 3, then it will be 3 2s are 6, 3 4s are 12, 3 3s are 9. So it is 243. Again, let's see whether it will go by 243 or not. So it should go. So if it is a perfect square, then it should go, because 3 should get another 3 to pair up, right? So this is one particular logic which you can get while doing prime factorization itself. So 3 8s are 24, 3 1s are 3. So 81. Again, if this particular 81 is going with 3 or not, let's check. So 81 divided by 3 will be 3 2s are 6, 21, 3 7s are 21. So again, let us do this particular 27 with 3. We will factorize this 27. So 27 divided by 3 will be 9. Again, if you do 3, then 3 3 1. So you have got 6 times 3. That means this particular 729 is actually equal to 6 times multiplication of 3. So now you can group this particular 3. So these two 3's will group up, like pair up, and these two 3's will get pair up. These 3's will get pair up. So bring 1 1 3 from each pairs and you multiply that with each other. So 3 into 3 into 3. What is 3 3's are 9? 9 3's are 27. So 3 into 3 into 3, you are getting 27. That means square root of 729 is equal to 27. So this is the symbol. This particular symbol is square root. So if you are writing a number under this particular symbol, then it shows square root of 729, that is equal to 27. So let me solve the sixth question in this particular fourth question. So sixth question has 9604 as its number. So 9604. You should go on doing prime factorization for this. So let us take 2. So 2 4s are 8, 2 8s are 16, 0 is there, 2 2s are 4. Again, if you factorize with 2, it will be 2 1s are 2 2s are 4, 2 4s are 8, 0 is there, 1. So here 8 3s are 24, but 0 1 is there. So this particular 2401 you cannot divide with 3. So let us see whether 2401 will be divided by 7 or not. So 7 3s are 21, 30 will be there. So 7 4s are 28, 2 will be remaining, 21. 7 3s are 21. So when you divide 2401 with 7, you will get 343. So here 7. So because 7 is also a prime number. So if you do prime factorization of 2401 with 7, you will get 343. Again, if you do this with 7, then you will get 7 4s are 28, 63 is there, 7 9s are 63. Again if you use 7, it will be 7 7, so finally you'll get 1. So now 9604 you can express it as 2 into 2 into 7 into 7 into 7 into 7. So again you can see here all the numbers have pairs. That means this particular number is perfect square. So 2 is getting pair with 2, 7 is getting pair with 7, and this 7 is also getting pair with another 7. So take 2 from this, take 7 from this particular pair, and take 7 from this particular pair. So 2 into 7 into 7. So 7 sevens are 49. 49 into 2, 98. So 98 is the square root of 9604. So square root of 9604 will be equal to 98. So let me solve the 10th question in this particular 4th question. So in 10th question you have 8100. So if you go on performing prime factorization for 8100, so let us take 2. So 4 2s are 8. So 1 is there. So here 1 0 will be coming. So 10 will be there, 5 0. So 4050 is the number which you get when you divide this 8100 with 2. So next again if you divide this with 2, you will get 2025. So again when you divide this 2025, it will not go with 2. So let us take 5. So when you divide this 2025 with 5, you will get 405. So again when you do this with 5, you will get 81. So again when you use 3 here, you will get 3 2s are 6, 3 7s are 21. So again when you use 3, you will get 9. Again when you use 3, you will get 3. So 3 1. So here you can see 2 into 2 into 5 into 5 into 3 into 3 into 3 into 3. So 8100 is actually equal to 2 times you should multiply with 2, 2 times you should multiply it with 5, 4 times you should actually multiply with 3. So this will be the these will be the prime factorization numbers of 8100. Go on grouping two numbers, like 2 will pair up with 2, 5 will pair up with another 5. These 2 3s will pair up and these 2 3s will get pair up. So you will get 2 from this, 5 from this, 3 from this, and one more 3 from this. So 2 into 5 into 3 into 3. So 3 3s are 9. 9 5s are 45. 45 into 2 will be 90. So the square root of 8100 will be 90. So coming to the 5th question. So this is actually a bit tricky question where they have actually given non-perfect squares. And you should actually find out with which number you should actually multiply that particular non-perfect square to get a perfect square. So the smallest whole number you should actually find to get a perfect square. When you multiply that particular smallest whole number to that non-perfect square, you should actually get perfect square. So coming to the first question in this particular 5th question, it is actually 252. So again use prime factorization method and try to find out which is the lone number which is left out without getting pair. So that number you can actually multiply, or let's see how it will go. So 252 is there. So let us go on taking prime factorization of this. So let us divide with 2. So it will be 1. So 2 2s are 4. So 2 2s are 4. 1 is remaining. So 6 are 12. So 126 is there. So again if you divide with 2, it will be 63. So this will actually go with 3. So 2 1. So again when you take 3, it will be 7. So again when you take 7, it will be 1. So here 252 is actually equal to 2 into 2 into 3 into 3 into 7. So here you can clearly see this 2 can get pair up with another 2. This 3 can pair up with another 3. Here 7 is not pairing up with anything. So 7 is left alone. So here you should actually multiply this particular number with another 7. Then only this particular number will become a perfect square. So the smallest whole number which you should multiply to this number is 7. Because when you multiply 7 with 252, this particular 7 will get a pair. So when this particular 7 is getting a pair, then this particular number after multiplying with 7, whatever number you will be getting will be a perfect square. So to make 252 a perfect square, you should multiply that 252 with 7. So the smallest whole number is 7. So the first answer is 7. So the second part in this question, they are actually asking to find the square root of that particular perfect square which you will be getting. So when you multiply 7 with 252, you are actually getting 7 2s are 14, 1 carry, 7 5s are 35 plus 1 is 36. So 7 2s are 14 plus 3 will be 17. So you are getting 1764. So 1764 is a perfect square. So when you go on performing prime factorization with 1764, then you will again get 2 into 2 into 3 into 3 into 7 into 7, because this 1764 is actually equal to this particular prime factorization. So here also you can see 2 and 2 get pairs, 3 and 3 get pair, and 7 and 7 can get pair, because we have multiplied 252 with 7. So we have got the new number, that is 1764, and the square root of this particular 1764 will be 2 into 3 into 7. So take 1 2 from this, 1 3 from this, 1 7 from this. So 2 into 3 into 7 will be 7 3s are 21, 21 into 2 is 42. So the square root of 1764 is 42. So the first answer is, you should actually multiply this 252 with 7 to get perfect square number, and using prime factorization method, again you can calculate the square root of this particular like perfect square number which you have got. So you can use the same previous method which I have shown, and you can calculate the square root of this particular perfect square. So square root of the 1764 is 42. So the first answer is 7, which should get multiplied with this non-perfect square 252, and whatever perfect square you are getting, if you take square root of that, you are getting 42. So there are 6 questions in this particular 5th question. Here also you are just going on doing prime factorization. Whatever number is left alone, you should put another number to pair up with that particular left alone number, and that number you are actually multiplying with the non-perfect square, means that particular perfect square you will be getting. So then using again with prime factorization method, you can calculate the square root of that particular perfect square number. So in this particular question you have 6 questions. I will just solve 2 questions. So remaining 4 questions you can actually solve. So now let me solve the 6th question which is there in this particular 5th question. So I will solve 6th question in this particular 5th question. So that is 768. So again I will go on doing prime factorization of this 768. So you can use 2 because this is an even number. So when you divide 768 with 2, you will get 2 3s are 6, 2 8s are 16, 2 4s are 8. Again when you use 2 and divide this 384, you will be getting 2 1s are 2, 2 9s are 84, 2 2s are 4. So again when you use 2, you will get 2 9s are 18, so 1 with the 6 will be there. So 2 6 are 12. So again when you use 2, you will be getting 2 4s are 8, 2 8s are 16. So again when you use 2, you will get 24. Again when you use 2, you will get 12. Again when you use 2, you will get 6. Again when you use 2, you will get 3. So here you can clearly see, so when you use 3, you are getting 1 finally. So here 768 is actually equal to 2 into 2 into 2 into 2. Just count how many 2's are there. 1, 2, 3, 4, 5, 6, 7, 8 2's are there. So 8 times 2 you can multiply, and one single 3 is there. So this 2 can group each other. So this 2 can pair up with each other. These 2 can pair up with each other. These 2 can pair up with each other. But this 3 is left alone. So the smallest whole number which should be get multiplied with this 768 is 3. So when you multiply this 768 with 3, you will get a perfect square number. So 8 3s are 24, 2 carry, 6 3s are 18 plus 2, 20. Again 2 carry, 7 3s are 21 plus 2 is 23. So 2304 you will be getting. So again when you do prime factorization of 2304, you will actually get 8 times 2, and after that you will get 2 times 3. That means the left alone 2, the left alone 3 is getting one pair. So here you can see this 2, this 2, this 2, this 2, this 2, this 2, and this 2 gets paired up, and this 3 and 3 gets paired up. So you can take 1 2 from this, 1 2 from this, 1 2 from this, 1 2 from this, 1 3 from this. So 4 times 2 and 1 time 3. So 2 into 2 is 4, 4 into 2 is 8, 8 2s are 16, 16 3s are 48. So the square root of 2304 or the square root of perfect square number which you have got after multiplying 3 with 768 is 48. So coming to the sixth question, this is also similar to fifth question, where in fifth question they have asked to multiply that particular number to that particular non-perfect square to get a perfect square. Now you should find a number by which if you divide that number, you should get a perfect square number. So here also you should follow the same prime factorization method and find whichever number is left alone. Now you should not multiply that number to the number which is given. You should actually divide that number from that particular number. So I'll just explain this with one particular question. So coming to the first question in this particular sixth question, again they have given the same number 252. So again when you find the prime factors of this particular 252, so you can go on doing factorization. So 1, 2 1s are 2, 2 2s are 4, 2 6s are 12. So again when you do when you use 2, you will be getting 6 3. So again when you use 3, you will get 2 1. So when you use 7, you will get 3. So when you use 3, you will get 1. So 252 is actually equal to 2 into 2 into 3 into 3 into 7. So here 2 is getting paired up, so 3 is getting paired up. 7 is left alone. This we have actually found out in previous question itself. Here you have actually find out the smallest whole number 7. So here you should actually divide this particular number with this 7 and that will be the perfect square. That means you are actually removing this particular 7. So you should actually divide this particular number with 7. So when you divide 252 with 7, you will actually get one number. That will be your perfect square. So 7 1s are 7 3s are 21. 42 will be remaining. So 7 6s are 42. So 36 is the number. So what is the square root of 36? Again you can actually use prime factorization method. So like you can use 6 or you can use 2. So 2 1s are 2. 2 8s are 16. Again you can use 2, you will get 9. You can use 3 3 3. So here 36 is actually equal to 2 into 2 into 3 into 3. So you can pair up these two. So one number is 2 and the other number is 3. You can just do 2 into 3, you will get 6. So the square root of 36 is 6. So the smallest number which you actually divide will give you a perfect square. So in previous question, you should actually multiply that smallest whole number. In this sixth question, you should actually divide the left alone number. So when you did in previous question, you actually multiplied this particular 7 with 7. That means you are multiplying this 252 with 7 to get a perfect square. In sixth question, you are actually dividing this particular 252 with 7 to get another perfect square, and you have also find out the square root of that particular perfect square, which is actually equal to 6. So like this you can solve the remaining problems which is there in this particular sixth question. Because this is very easy problems, like you can easily go on practicing the problems which is given, so that you will be much more well versed in finding perfect squares. You will be much more well versed in finding square roots using prime factorization method. Coming to the seventh question in this particular exercise, for a Prime Minister Relief Fund, a class of students have given 2401 rupees in total. And one hint which they have given here is that, so how many students are there in that particular class? So that much amount each student have given. That means if 10 students are there in a particular class, then each student have given 10 rupees. So if 100 students are there in a class, then each student have given 100 rupees. That means if every student has given 100 rupees and 100 students are there, then 100 into 100 will be 10,000. So like this, they have given 2401 as number, and they are giving one hint which states that how many students are there, that much amount each student has paid for this relief fund. So here 2401 is there. So just find out the perfect square, like square root of this 2401. You will get how many number of students are there in that particular class. So let us go on doing prime factorization of 2401. So let us see whether this will go with 7 or not. So 7 3s are 21. So 3 is there, 30 will be remaining. So 7 4s are 28, 21 will be remaining, 7 3s are 21. So again let us do with 7. So it will be 49. So again you do with 7, you will get 7. So again you do with 7, you will get 1. So 7 into 7 into 7 into 7 will be equal to 2401. Just take, you just pair up this particular 7. So this 7, this 7, this 7, this 7 will get paired up. So here take one 7 from this and take another 7 from this. So 7 into 7 will be 49. So total 49 students are there and every student has paid 49 rupees. Coming to the 8th question in this particular exercise, they have given, so in a garden 2025 trees should get planted. So in such a way that number of rows and number of columns should be same. So if you are actually planting a trees in a particular ground, if you plant 5 trees in a row, then 5 trees should be there in that particular column as well. So this is actually columns and this is actually rows. So here if 5 rows are there, then 5 columns should be there. So in this fashion you should actually plant this 2025 trees. So here indirectly you should actually find out the square root of 2025, because if you want to plant 2025 plants in a garden, so that number of rows will be equal to number of column, that will be equal to rows into column. That means here you are actually multiplying number of rows and number of columns, and number of rows and number of columns are same in number. So that actually shows you are multiplying the same number 2 times to get a number. So total number. So that is actually equal to 2025. That means indirectly you should actually find out the square root of 2025, and you can easily calculate how many rows and how many columns you should actually put in that particular ground. So let us find square root of 2025 using prime factorization. So this will go with 5. So 5 4s are 20, 0 will be there, 5 5s are 25. So 405. Again when you divide this 405 with 5, you will get 81. So this will go with 3. So when you actually divide 81 with 3, it will be 3 2s are 6, 21, 3 7s are 21. So again this can go with 3. So 9 will be there. Again this can go with 3. 3 will be there. 3. Again if you divide this 3 with 3, you will get 1. So here you can easily see this 2025 is actually equal to 5 into 5 into 3 into 3 into 3 into 3. So you can go on grouping. So this 5 pairs up, this 3 pairs up, this 3 pairs up. So take one 5 from here, take one 3 from here, take one 3 from here. Just multiply this. So when you do 5 into 3 into 3, you will actually get 5 3s are 15, 15 3s are 45. So total 45 rows and 45 columns you can do, so that you can fit all 2025 plants in a ground where 45 rows and columns will be there. Coming to the 9th question, they are actually given 3 numbers 4, 9, 10. So you should find smallest perfect square which is actually divisible by all 3 numbers like 4, 9 and 10. So for this you can take LCM of 4, 9 and 10 and you can actually calculate which is the leftover number that you can actually multiply. So here 4, 9, 10, if you go on taking LCM of this, so this will go with 2. So 2 2s are 4, 2 5s are 10, 9 will not go with 2. So 9 will be remained like that. So again if you take 2, it will be 1, 9, 5. So here this will be going with 3. So 1, 3, 5, 3 will be remaining. So 1, 1, 5. So 5 you can actually take here. So it will be 1, 1, 1. So now you have found out what is the LCM of this 4, 9 and 10. So it is actually 2 into 2 into 3 into 3 into 5 into 1. So here let us ignore this 1. So 2 and 2 can get paired up, 3 and 3 can get paired up, but this particular 5 is actually not getting paired up. So now let us actually multiply all these numbers. So here you will actually get 2 2s are 4, 3 3s are 9. So 9 4s are 36. 36 into 5 is actually 360 divided by 2. So that will be 180. So you are getting number 180. So this 180 is actually divisible by 4, 9 and 10, because we have found out that by taking LCM of 4, 9 and 10. So you have got 180 as your LCM, but this 180 is not perfect square, because this 180 will get 5 if you do prime factorization of 180. That means 5 will be left out alone. So now that 5, if you multiply with 180, you will get that smallest perfect square number which can be divisible by all three numbers, that is 4, 9 and 10. So 180 into 5 will be 18 5s are 90, 900. So 1 0 is there, so 0 I am putting. So 900. So 900 is the smallest perfect square which is actually divisible by both by all three, that is 4, 9 and 10. Similar to 9th question, in 10th question also they have given three numbers and they have told to find the smallest square number, like perfect square number which is actually divisible by 8, 15, 20. So let us take LCM of 8, 15 and 20. So let's see what will be the answer. So here we can take 2. So 2 4s are 8, 15 will be as it is, 2 10s are 20. So again you can take 2. So 2 2s are 4, 15, 5. So you can take 5 here. So it will be 2, 3, 1. So again you can take 2. It will be 1, 3, 1. So you can take 3. It will be 1, 1, 1. So the LCM of 8, 15, 20 is 2 into 2 into 5 into 2 into 3. So you can actually see here this 2 gets paired up. But this 2 is remaining alone. This 5 is remaining alone. This 3 is remaining alone. So when you multiply all these 5 numbers, you will get 2 2s are 4, 4 2s are 8, 8 3s are 24. 24 into 5 will be 240 divided by 2. So that will be 120. So after multiplying all these numbers, you are getting 120. So 120 is the LCM of 8, 15, 20. That means this particular 120 is divisible by 8, it is divisible by 15, it is divisible by 20 as well. But this is not a perfect square because it has one lone 5, one lone 2 and one alone 3. So here you should actually multiply this 120 with 5, 2 and 3, so that 5 will get another pair, that 2 will get another pair, that 3 will also get a pair. So you should actually put one pair for all the numbers. So you multiply with 5, 2 and 3. So 120 should be multiplied with 5, 2 and 3, because these 5, 2 and 3 are not getting pairs. So again, so that's why we are actually putting one more 5, one more 2 and one more 3 for this 120. So 120 into 2 will be 240, 240 into 3 will be 720, 720 into 5 will be 7200 divided by 5. 7200 divided by 2. So that will be 3600. So this 3600 is the lowest perfect square number which is actually divisible by 8, 15 and 20. I thought I will finish this particular chapter in part 3 video itself, but this part 3 video is getting lengthier. So I'll be doing part 4 video as well. So totally this particular chapter now it will be containing 4 parts. So if you want to learn squares and square roots chapter properly, then refer my 4th part as well, like 4th video related to squares and square roots as well. So you can go to the playlist section of my YouTube channel and there you can easily find out wherever that particular subject is there, like 8th standard mathematics, 8th standard science, like that, like different playlists I have been created in that particular YouTube channel. So if you want to learn physics, chemistry and mathematics related to 8th standard, 9th standard, 10th standard and PU, then please do subscribe to my channel and stay tuned with my channel. Thank you.